In this video, I wanted to talk about some of the quirks of writing out a series using summation notation. In this case, here's our sigma, the big E, and our starting value for n, our index, is 3, and our ending value for n is going to be 7, and here's where we use n in the actual formula or rule for the nth term. And again, by the way, this guy right here is our nth term. It's a sub n, okay? And in other words, it'll be our a sub 1, it'll be our a sub 2, it'll be our a sub 3, and so we'll keep going like that. Anyways, let's go ahead and write this out. So if we go to write this out, we'll do something like this: 5 to the 3 minus 1, and then we will add that to 5 to the 4 minus 1, because the n is being incremented by 1 from 3 to 7. So we'll add that to 5 to the 5 minus 1, plus 5 to the 6 minus 1, and finally plus 5 to the 7 minus 1. Now, the reason why I'm asking you to write this all out is because it's really hard to understand this without really actually getting in there and trying it yourself and visualizing what's going on. I want to point something out that's very interesting here. In this particular case, I want you guys to notice that our first term is right here, and but we'll actually, I guess we could refer to that as a sub 1, and then our second term's a sub 2, a sub 3, a sub 4, a sub 5. What I want to point out to you is that this guy here, this last term, even though we use a 7 to get it, it is not the 7th term in the sequence or the series. It's the 1, 2, 3, 4, 5th term. And so if we had to count up and say what is the number of terms that are represented by this sigma notation, we would say 5, not 7. A very common mistake is to assume that this 7 is the number of terms, and it's not. The way that we get the number of terms, and here's another little weird quirky thing, is that a lot of times we will use n to represent the number of terms, even though it's also representing the index of each individual term. So this is a little bit, unfortunately it's a little confusing, but I wanted to present you with this idea so that you'd be exposed to it. We're going to say that n is the number of terms, separately from the fact that n is also the index of each individual term. Okay, so there's a little rule that we can use to calculate how many terms we're going to get, and that rule is we take the number on top, we subtract the number on the bottom, and then we add 1. So we will do top minus bottom plus 1. And that rule works every single time. And in our particular case, it gives us 7 minus 3 plus 1, which is 4 plus 1, or 5. And I want you to notice that this is the number of terms in our sequence or series, and it matches up with the fact that we could count 1, 2, 3, 4, 5. So those are two little things that I wanted to share with you, is that this number is not the number of terms. To get the number of terms, you have to take this number, subtract the bottom number, and then add 1. And one last thing is that sometimes we'll use the letter n interchangeably for the index of each individual term, and we'll also use it to represent the number of terms. Now notice over here that we also use an n when we say a sub n, but here the n just represents, it's just the subscript for the a, meaning that this guy right here could be any one of these terms. All right, that's it.